Hi, I'm Tom Clifford, and this is Engineering 1 and Engineering 2. I'm going to put both these two classes together. So I just want to talk a little bit about the classes and what your students can expect. I really enjoy teaching these classes. It's a lot of fun. It's pretty creative. We have different kinds of competitions. Kids seem to enjoy that. They get to get up and move around. It's a lot of trial and error. So some of the fails are kind of fun as well. So that it's an enjoyable experience, and we're able to make some things that are pretty impressive. So just a real short history lesson of engineering at Carmel High School. Currently the two classes, Engineering 1 and Engineering 2, they're not really sequential. We're working to change that and make that into a more sequential experience where Engineering 1 really lays the foundation, Engineering 2 really gets in deep, and students are able to use the knowledge that they have from Engineering 1 as they focus really on robotics. So we use some curriculum called Project Lead the Way, which is a nationally known program. It's UC approved, so that's really good news for us. Getting new courses approved by UC can be difficult. And this is a program that the University of California recognizes, so your students are getting UC credit for this class. So what we'd like to do is to really provide students in Engineering 1 with a foundation, understanding design, understanding CAD, understanding principles of engineering such as simple machines, having some experiences in the shop building some things, but really laying that foundation so that things are really clear and that they do have a good understanding going into Engineering 2. We'd like to move Engineering 2 specifically to robotics. So we have an after-school robotics team. There are some students in the class that are on the team, which is lovely, but that's not a requirement. So kids in the class don't have to be on the team. Kids on the team don't have to be in the class. But nonetheless, we're still working on the same goal, that we're building a robot, we're understanding how to construct and design and mechanically create the thing, we're wiring things up so we understand the electronics of what's happening on a given machine, on a robot of any kind of size and shape. And lastly, that there's an introduction at least to some code, some software. So without software, without the code, we just made a nice paperweight. So being able to understand a little bit about the software that one needs to write in order to get a motor to turn on or turn off, a sensor to pick up information and respond accordingly is an important component. So that's where we've been, and that's where we're headed. Engineering 1, the main focus is, as I said, is on design and on the principles of engineering. As well as shop safety. We have a lot of really powerful and very impressive tools in our robotics lab and in our auto shop, and we use that in class so students know the safety procedures and the protocols to use those tools and machines successfully and safely, and then they're able to put that knowledge to use and display their capabilities and their skills as they create different types of projects. A lot of the projects that we do at the beginning of the year tend to be fairly small in class, make things with kind of crafty types of material, and then we move on to bigger and better things as the year goes on. So in Engineering 2, this is really an introduction to robotics. And so we have a number of smaller kits that we like to use, so kids do still have to employ the design, the CADing, and the mechanical concepts that we've covered in Engineering 1, but then to apply them really to a robot in particular. So similar to Engineering 1, again, we go over shop safety thoroughly. We go over an introduction to how do robots actually work, what's the wiring, how does a motor work, and we kind of dive a little deeper into some of those topics that we've introduced and presented in Engineering 1. The two kits that we have Arduinos, so fairly small and pretty simple, but pretty neat, I think. Kids really do kind of learn a lot about engineering and electrical engineering in particular. understanding the flow of electrons through a given circuit, and using a microprocessor in order to control information. And then we have Tetrix kits, which are a little bit bigger, there's no welding, there's no cutting of material. That the kits come with parts, and kids are able to make their machines and try to figure out, okay, and the best way to deploy gear ratios and those sensors that we've been using in some of those Arduino types of kits. The projects in Engineering 2 tend to be more real world because these are actual problems that we need to solve for our robotics team. So there's a working together between the team, the after school team, and the class. There are a number of projects that we need done as a team that the class will then deploy and use. Because of that, there's a lot of different types of projects that students can work on. So if their interest is mostly in mechanical, there's a lot of building that we need to do. But there's also a lot of electrical. There's a lot of team building things, such as we need a website developed. We need some organizations and organizational things in our shop and for our pit. And so we use the class as a way to kind of bolster some of that up. So kids in the class are actually working on things that we're going to be using when we get to competition, and as we start to develop our robots in greater detail. There still is a fair amount of CAD that students need to do. The CADing that we use is Fusion 360, made by the Autodesk Corporation, which is industry standard, and kids are able to make some pretty cool things with that. We also go into a lot of the mechanical issues as well, touching on some of those same topics that are covered in Engineering 1, but as I said, going into greater depth. Same thing with the electronics, really understanding how that robot looks. When someone new looks at one of our robots, they look really, really complex and super complicated, and I guess they are, but we really want students to have an appreciation and a strong understanding for how that actually works. What we do on those robots is pretty typical for what happens in any kind of electrical system. We need some power, we need to distribute that power, we need speed controllers, we need sensors, and all of that needs to talk together. There is a little bit of programming. This isn't a computer science course, but I do want my engineers to at least be appreciative and understanding how that software works. And so to be able to look at some code and or at least to be able to communicate to a programmer, this is what we need to do and how and why, is really kind of the critical topic. These are some of the major topics and the skills that we have, and it does kind of cross over in both courses, so that students are able to, again, have an understanding of engineering, both in the micro and macro level, being able to use equipment and tools safely, and be able to then apply that in a real world sense. Typically in the class, we do almost all of this in class. There's not much homework. There's no textbook. I usually do not assign homework. There's no worksheets that I'll be assigning. We might do some quizzes and tests. Those are fairly straightforward. They're based on what we're doing in class. And that's really just to make sure that students are safe, students understand the concepts, and are moving things forward. Most of the grading is done either through participation. Are you there? Are you working hard? Are you doing what we're supposed to be doing? And how are you successful at being able to produce some of the projects that we do? So that's it. That's engineering, both 1 and 2, in a nutshell. If you have any questions, don't hesitate to call me or to email me. Email is probably the preferred method of communication, but I look forward to seeing you in person, and thanks for watching.